All right, let me try a solution here from our rotational kinematics, really our last one on mechanics. They've got this picture of a motorcycle wheel, and I printed it. I didn't actually print the question. I'll read you the question. It says, calculate the rotational kinetic energy of a motorcycle wheel. See this figure, 38, okay. So if its angular velocity is 120 radians per second, its mass is 12 kilograms, and it has radius 1 and radius 2. Now let me pause right there, because it says here, and this is the important step, that the motorcycle wheel has a moment of inertia that you can approximate as an annular ring. Okay, so an annular ring is really just kind of a ring that is got a thickness to it. And that does seem to match this motorcycle tire really well, because it's got a inner radius of R1 and then an outer radius of R2. And that's where the mass is, between this inner radius and outer radius. Don't confuse that with this little r. That's actually the force in the chain, and that's the torque making the wheel go around, and that's not part of the moment of inertia. In fact, then, the moment of inertia of this gets a bit complicated to calculate, and as I told you guys, we will skip over on trying to calculate that. We'll leave that for the engineering class. But we've got this nice table we can look it up, and so I noticed it's listed right here. Here is an annular ring or cylinder about its center axis, and it looks like it's a 1/2 m, and then it's the inner radius squared plus the outer radius squared. All right, so I'll just take that little formula and write 1/2 times m times inner radius squared plus outer radius squared. And use that as my first piece of information, because the problem, listed very clearly the mass was what, let me look up here, what does it say? 12, okay. And the inner radius is 0.28, so I'll square it. And the outer radius is 0.33, so I'll square that. And of course, this is in units of kilogram, and this is in units of meter, so square meter. And that's the perfect and the appropriate units we want for the moment of inertia or rotational inertia. So the rotational inertia here is, let's see, 0.28 squared plus 0.33 squared. All right, so that's this term. And then we can multiply that by, and I'll just do half of 12, that's a 6, and see what I get. All right, so it looks like it's a 1.12 kilograms times a square meter for the moments of inertia. All right, let's not forget that. Now I can actually do the problem. And the problem then is, like a lot of our rotations, just how would you do it if you did translational motion? You would go 1/2 mv squared. So using the analogy of formula with that would be 1/2 I omega squared. So there's the 1/2. The I we just calculated, the moment of inertia, was 1.12 kilogram meters squared. And the rotational speed of the wheel was given. Let's see, calculate the rotational kinetic energy of a motorcycle wheel at 120 radians per second. Now, I'll take this as an opportunity to talk about the units again. It doesn't really look like anything cancels off, and it looks like we're still left with this radian squared. But this is my chance to say yet another time, radians is not a real unit. The definition of an angle in radians is an arc length over a radius. So it's unitless. We throw it in there just for clarification, because it would sound funny if we didn't have it. We would just say the speed would be 120 per second. Like, well, 120 what? So to make it clear, we're talking about radians. We say radians. But sometimes that clarifying word radiant actually makes things worse. So if it does, throw it out. So that's what I'm going to do here. Because a kilogram meter squared over second squared is a joule, and that's what we're after. And so hope you won't be too bothered by me just saying, I'm not even going to think about the radians. It doesn't cancel off. It was never a unit to begin with. It was just a clarifier. Now it's not clarifying. In fact, it's making things worse, so let's get rid of it. So good, the answer comes in joules, as it should, because it is an energy. So let me take that moment of inertia, which is already in my calculator, and multiply it by 1/2 and multiply it by 120 squared. And I get 8,000. And maybe to 3 significant figures, I'll call it a 90. So 8,090 joules. Was there a part B to this? No, there was not. All right. Hope that helped.